My name is Vishnu Dutt, and I have Prashant Rohit with me. And the agenda of today's session is going to be very, very interesting, right? We are into the session number 10. And what we are talking about here, we are talking about Cisco Certified Network Associate. Yesterday, I was having a look at CCNA syllabus, and then I came to know that 65% of the syllabus is already done, right? But yes, there is some ambiguity with respect to that 65%. And the reason is that CCNA is actually a huge, what we can say, certification, right? It involves a lot of technologies. But yes, believe me, if you have gone through all the recordings, whatever we have recordings of the classes, if you have gone through everything, then you should for that too. How to prepare for that? Maybe sometime when we meet in the office, I will let you know, right? But in the meantime, your responsibility now is to make sure that you complete all the classes. Having said that, what is the agenda of today's session? The agenda is going to be that we are talking about automation and programmability, right? And we have our automation expert, right? He has been doing this automation for a lot of customers. He is responsible for many customers, and the big customers like HSBC, right? And he has written many code through which he is doing the migration process without the manual intervention. So he is pretty good with respect to automation, and the name is Mr. Rohit. So the starting 2 hours from 9:30 to 11:30, Mr. Rohit will be talking on automation and programmability from the viewpoint of Cisco Certified Network Associate, right? If it is possible, if Rohit, it is possible, then you can take a break at 10:30 for 15 minutes, and then you can take the session till 11:45, so that these guys also get the breather in the meantime, right? Once Mr. Rohit is done with the session, we have another expert with us today, because wireless is another important piece in CCNA. At least you should have knowledge about it, that what wireless does for us, right? Because we have been talking about computers and we have been talking about switches, and we always say that the computer or the laptop is going to connect with a switch with this Ethernet cable, right? But how many you see that your laptop is connected via Ethernet cable? No, right? This cable is not there at all. Why? Because we have wireless infrastructure, and every organization, doesn't matter where you go, if you're part of any enterprise, you will see wireless infrastructure there. You do not need to connect this Ethernet cable, right? So there are some fundamentals behind this wireless technology, and Anumol is going to talk regarding that once Mr. Rohit is done, right? Having said that, Rohit, it's all up to you, right? Take the control and let's start something in automation and programmability. Thank you so much, Mr. Rohit.
Thank you so much, Vishnu, for the humble introduction. And good morning, everyone. My name is Rohit Mandirata, and I have been already introduced, so nothing much to say. I'm part of Cisco migrations team, part of PSTG Enterprise Migration, working for various customers, specifically for HSBC. And today I'll be delivering this session on automation. And as we always say, let's start with the why, what, and how of the requirement basically behind this network programmability and automation. So first things first, let me start sharing my screen. I hope the screen is visible.
Yeah, your screen is visible, Rohit.
Yep, that's the right view. Okay, so the intention or the intent behind this session is, in very layman terms, is we want to interact with the network using automation. we have seen a lot of lab sessions that you have attended in previous days, possibly 7 or 8 days, that we have devices in the network on which we are trying to provision network services. And when I say network services, these are all the networking protocol that basically are required to make our services, make our application work, right? So be it running OSPF on the network or STP or NET, right? To do all these things or to provision all these things, we generally interact with the devices. How? We take SSH session, we take console of the box, we can interact with the device in various ways, right? So this is the traditional way of interaction with the boxes, right? So logging into the boxes using SSH or any equivalent. What we get the data in human readable format. So generally, when we run any show command, what we get, either we get the operational data, that is what is the status of the device, okay, how it is performing. Say I am typing a command show IP OSPF neighbor, right? So it is going to tell me, okay, this is your neighbor, this is the status for this neighbor. Probably if you dig deeper, you can get to learn, okay, these are the LSAs that you are receiving from these neighbors, and because of these LSA rating, that route is getting into the routing table, right? So these kind of data is basically the operational data, and we get that in a very human readable format, right? There is going to be some commentary about that command. After that, there is going to be a table, so that each and every engineer would be able to understand that outcome, right? And so when we are saying that we are trying to understand that outcome, let me use a more technical word, that is parsing. So when I read the information that gets displayed when I type any of the command onto the or let me grab a pen, right? With that it will be more interactive, right? So allow me a moment.
Yeah, so in the meantime, everybody, if Mr. Rohit is saying log in into the device, the meaning is that we have a switch or router, right? And we connect a cable to it, and we call that cable as console cable. And literally, once we get the console cable connected to our laptop, we can start giving commands to switches or router. This is what Mr. Punish or Dhaval was doing, right? They were clicking on the device. The meaning is actually you were connected to that device. But in the real world, in the physical world, you are going to have a physical device amongst you, right? And you are going to have a laptop with you. How you are going to connect with the device? There are multiple options, right? You can connect a cable, which we call the console cable, to the device, and then
Just
basically, yeah.
2 more minutes. I'm just setting up my
No problems, no problems.
pen.
So if you can just
Oh,
connect via
where's the
console
last one?
cable.
Let's set up.
Yeah. Okay. Am I audible, guys? Anybody?
Yeah, Vishnu. Yes.
Okay, perfect. So just think that if Rohit is saying log in into the device, the meaning is you are connected with the device. There are multiple options to connect with the device, and I will let you know in next class that how to connect to the device. But yes, he just wanted to say that you can connect to the device and you can execute some command, which we have been doing.
ऊपर कैसे होता है टेबल इधर से ऊपर हो रखा है मैं खड़े होकर काम करना चाहता हूँ इधर आ जाना मुझे
Right, I'm back. Let me do some scribbles.
चेयर ऊपर कर लेना अपनी अभी तो अभी काम करते हैं.
Yeah, Mr. Rachit Puri, could you please on mute? Thank you so much.
All right. Okay. So, what I was talking, like, how we generally interact with our network. Say, what we do, we run some sort of show command, right? Probably a show version. And what it is going to give us, it is going to give us line by line information. Okay, that is human readable. At some point in point of those lines will have, say, OS version mentioned, probably 16.3.2 something for XE. Then there is going to be some of the information. Post that will, say, have information related to, say, memory of the box. Okay, this box has got this much of RAM. This is the serial number of this box, so that we can identify that box uniquely. These kind of information, right? And when we interpret this information, right, we are trying to get some meaningful outcome out of this information. That is called basically parsing, right? So what we are trying to do when we get line by line information from the box, we interpret that information, get the consumable data for us that is important for us, right? Some kind of consumable data, be it OS version. Maybe we are interested in that. We want to identify the device. We are interested in serial number, right? So these kind of data, when we take from the box, this is called basically parsing. Now, this parsing can be human parsing. So when I'm reading this data, okay, because I'm a network engineer, I know what is the meaning of OS version, what is the meaning of serial number. And this parsing can be automated, right? So what I'm doing, I'm creating some sort of automation, right? Not jumping ahead of the time, but some sort of automation in which in layman terms, I am asking a program on my machine that interact with this box, okay? Parse the data and get me the required information, right? So in your college projects, you may have use a term called regular expression. Don't worry if you haven't used it, but this just reciting a common use case, right? So we generally use regular expression to fetch the required information from a line by line data. So this is basically the traditional way of interaction with the box. So what we do, we access the box, we run some show command, we can apply some configuration on the boxes to provision the services, and the output that we get from there, that can be interpreted by a network engineer or through some sort of script, right? So these are the traditional ways of interacting. Now, with that, there are some limitations as well, right? So suppose we are say logging into the box, taking some sort of information. With that information, we are trying to provision some service, be it OSPF, BGP, and whatnot, right? So the time that is required to provision that service is quite huge if we compare it with the other services, with the other business logics. And why I say that, say a developer is saying that he'll be able to say create a service, say a report generation tool, and the timeline that he is giving to the business is somewhat 2 weeks, right? So developer is saying, I'll be able to create a web page that is going to provide you a report in 2 weeks. Now, network obviously would be required because the developer is going to create a service here while user is sitting here, right? So in our good, like introducing our good old friends again. So Rahul is basically the consumer of the service, and Anjali is the developer, and she has created a code and has deployed that code here, right? And what she said that she'll be creating this code, this development, this application that is going to generate some sort of report. And report is, I mean, any kind of report, right? Probably a attendance report for a college project, right? These many students were project in this session, these were absent in this session, some sort of report, right? And Mr. Rahul is the consumer for this report, right? So he want to create maybe merit based on this attendance for these students, right? So when Mr. Rahul wants to access this application, there should be a network in between so that he can interact with the service. Now, Anjali is responsible to create the development, the application, but someone has to create this network as well, right? And when Anjali reaches out to this team who is going to create the network, they say that, okay, it's a huge task. We need to provision some switches for this. We need to create some VLAN. We need to create some routing, and it is going to take us 2 weeks. Now, with this information, the business frowns. Okay, my application developer is taking 2 weeks. Now you are saying that to create that infra, you need 2 weeks altogether, right? So between those 2 weeks, though this application developer has completed his or her task, but Mr. Rahul is not able to consume that information. So that is too much turnaround, right? So this is where these manual way of configuring network poses a challenge, right? So time to provision and network service is huge with this manual interaction. Second limitation that we have is with the recurring task, right? So suppose to again coming back to same logic, suppose there are 10 routers between Rahul and the Anjali's application, right? These are 10 routers. And all those 10 routers, we need to configure a similar service, that is OSPF, that's all, to provision routing, right? That means we'll put router OSPF something and network command and say we want to apply network on all the ports. So that means that network statement will be same for every router, right? So that means we are implicitly applying common configuration on all these 10 boxes. So what we are doing here is some sort of recurring thing. We log in onto the first router, apply the config, log in onto the second router, apply the config, third, and so on and so forth, right? So if we want to do the same thing on all the boxes, why do this manual effort? Why not automate, right? Let's log in on all the boxes as one time and let the automation configure all these boxes. So if the tasks are recurring, it's automatable. We do not need to think about it, right? It's very, we know, okay, all these boxes are going to serve a similar purpose. So let's automate the configuration while log in again and again on all those boxes and do the similar thing. So that's one thing. The third thing is scale. Now, right now we are talking about only 10 routers. Suppose this application is not deployed here, but it's deployed far away and we have some 250 routers in between. And on top of it, nowadays applications get deployed on cloud, right? Not on the bare metal server. So suppose there is after these 250 routers, this is Mr. Rahul, there are 250 routers in between. There is a cloud here and cloud has its own infra. So the scale of the network, right? Earlier we used to have say 3 or 4 switches between this application created by Anjali and the consumer Rahul. Now the scale has become really huge. Rahul is sitting here. There are a huge network infra in between. And after that, the application is getting deployed in the cloud. Right? So the scale of the network has become huge from its inception, right? The network, say, when in 1970s the TCP was designed, it was designed with a thought process of the networks that were available at that time. Now that capacity has we can say like expanded too much that it will take numerous time if we are configuring this entire infra in between from the consumer of the application to the actual application or the location where the application is deployed. Right, so these are a few limitations. I mean, there are going to be many more, but on a high level, these are the limitations that we see when we configure or interact with our network in a manual fashion, right, or in a traditional fashion. So what do we need? We know the challenges. Now, to solve the problems, we need to like bullet out a few things, right? So suppose we know that, okay, I'm hungry. So if we want to solve that problem, so we need to come up with the ideas of satisfying our hunger. Say we should go to the market and buy some groceries or buy some oil and whatnot, right? So to solve this problem of the limitations that we have with this manual interaction, what we need. So what we are looking, we want to have some sort of programming interface. When I say interface, it's a common point that device can understand and the user can understand, right? So there should be an interface on which this network person, right, this network engineer, when he is interacting with the device to configure this device to provision the services, there has to be a common interface that both of these can understand. So there has to be a programmatic interface between the network engineer, that is us, network consulting engineers, and this device, that is a router or a switch or a firewall, could be anything, right? So we need to create something that both of these can understand and can talk based on the rules that will be governed with this interface. Second thing, we need to isolate the configuration and the state data. What do we mean by this? Configuration data is what we want a device to do, right? So suppose we want a box to run OSPF. So configuration data would be like something, this router OSPF something and network command something, right? So this is generally is the configuration data that we get from a show run command. State data is how the device is working with that service. So suppose I apply this configuration. Now, if I want to check whether we have the neighbors in place, whether I am running LSAs or not, so those are the things that are state data. So when I say show IP OSPF neighbor, right, and the output that I get from this command is the state data. Now there can be multiple state or the operational data that is present on the network, right? So the data can be related to the protocol, the data can be related to its interfaces, say interface gig, whether that is up, whether that is down. So all these things. So we need somehow to separate these two things. The configuration data should be separated from the state data. There should be a thought process or the mindset as well that we are going to configure network services, not network device. So when I say that there are some hundreds of devices between this application and this consumer, and we want to provision the network in between or make the network capable of having communication from this point to this point, there should be a mindset that we are not going to configure 1 box, 2 box or 100 box, but we are going to configure a network service. And what network service is this? This is network routing. This is network access control, something like this, right? So rather than talking box to box, okay, configure router OSPF, configure router OSPF, configure router OSPF, no. What we are saying, configure routing on this entire infra so that consumer can talk to the application. And we know the network can be error prone. There are things that are out of our control. Probably the link bandwidth is choking right now. Due to some power outage, there is a router is down within the infra. So there has to be a feedback loop wherein with the automation, we are continuously probing the network, figuring out whether that is functioning properly. If it is functioning properly, well and good. If not, let's do the changes that are required automatically. Right? So all the tasks that we were doing manually, what we are trying to do with the automation and programmability, we want to do all these in an automated fashion. So now we know what we need, right? First things first is the interface. And that interface is API. So you would have heard this term in like your engineering courses as well. API stands for Application Programmable Interface. So basically, if one machine wants to talk with the other machine, right? So say this is my application, or this is my device. This is my network admin, and he is running some sort of machine to configure this routing device, say router 1. And this router 1 provides a kind of API to this user or the network admin so that they can configure it. So this is what I mean, in very broad terms, application programming interface in case of our network would look like. So what we do, one machine talking to the other machine. I know we have a network admin, but somehow he is talking to this machine with this laptop, right? A network admin cannot talk to this router directly saying that, oh, hey router, how are you? Or hey router, what is your OSPF? I mean, he's going to use some sort of client in his machine to talk to this router, right? So, and in this client, rather than using the traditional way of talking to this router, now this network admin, what he'll run, he is going to run some sort of application, a network application, you can say. This network application is going to talk to a router or a switch that have this interface or API available that is exposed to the rest of the infra to which this network application that we are trying to build can talk. So earlier, my network admin to provision my network admin to provision any service on the router 1 or any switch, he was using a client called putty or secure CRT or anything, and he was running OS related commands. Now what we are trying to do, this network admin is going to create some sort of application, or if he is not creating, he is going to consume a network application, use a network application to configure one or many routers or switches or any network devices that have got an API available to interact. I'll just give a pause here. Are there any questions till here? Right. So now later we'll be discussing one more concept, that is southbound APIs and northbound API, and I mean this these are just the classification of the API. So how like we work with these APIs. So this classification will be taking when we'll be talking about the software defined networks or the control plane and the data plane separation. So for now, we'll just park these two things. For information perspective, let's keep in mind that there are going to be two kinds of APIs. One is southbound and one is northbound. And this point we have already covered that both when we have an interface in between, so this application, network application and these routers should be able to understand the language that they are communicating over. So the data formats or the data models that they are using should be in such a way that both of these agrees and understand. Right? So with that, now we'll come towards how this communication can take place. A network application talking to a network device. Generally, this class of network application is called model-driven programming, right? And we need three things to accomplish this. One is a data model. So what we want to define the rules, right? And what are the rules? Say an IP address, right? So we know a IP address is like 4 octets, but how would a machine know? So we need to define few rules. Okay, the IP address ranges from 0 to 254. There should be, or you can say the number, there should be for IPv4, there has to be 4 octets defined, and each octet ranges from 0 to 255. And this becomes a rule. So what data model does? It defines the rule of all the elements that we may be configuring on a network, on a box, and whatnot. So as I took an example, IP address can be a rule. Say we want to talk about the state of an interface. It's either can be up or down. Right? It could be error disabled. Could be something else, right? So we need to define, okay, if we are talking about the status of an interface, these three are the options. Say we want to talk about a VLAN. So we need to tell that, okay, in general, the VLAN range should be 0 to 4094. We are not going to consider a VLAN number beyond this range for BGP, right? So it should be, say, below that 2 power 16 range, right? The BGP AS number. So these kind of rules we need to tell to our model, basically. So this is data model, the rules that is going to govern our data. Now there has to be a format associated. So we know, okay, these are the rules. If I am talking about interface, it has to be, say, interface is a gigabit Ethernet. So interface name is going to be a string for me. Interface status is going to be Boolean, either up or down, 0, 1, something like that. The VLAN ID should be between this range, but there we need to present this data. We cannot present this data line by line, right? There has to be an agreement on which both machine and humans are okay. So there are few formats that have been agreed, like and they all have their pros and cons associated. So this data either can be represented in form of XML, that is extensive markup language, in form of JSON, right? JavaScript object notation, and YAML. So YAML is basically it's YAML and markup language. So it's a cool acronym basically that repeats itself. So you can search for it on Google. So if we move from left to right, so it's like XML is good for machines. When I say good for machines, it's more machine readable, less human readable. JSON is something that is like good for both. Humans can read it, machines can read it. And when it comes to YAML, it is very, very, very human friendly. Like it's more like a text written in English. So these are, and I'll be getting in some details of how these formats are written. Now we know the rules, right? We know the grammar. So Yang is basically the grammar. We know the format. Say it's going to be English. Okay. So Yang is English grammar. Data format is say JSON is English for us. Now we need to transport this from one point to the other, right? And here our old friend TCP is going to come into the picture, right? We'll be again using TCP and its port. So we have the data in place in a certain format, written in certain format. So this is the data, this is the format, and we need to transport it. So let's use TCP that is already available. And what engineers did, or the protocol inventors did, they said that, okay, let's use few of the, let's create a new protocol to transport this between an network application and the network device. So there were few options given. So netconf is basically a more usable or more, you can say, a network friendly protocol. It runs over TCP port number 830. RESTconf is basically a way of using the existing REST APIs. So when I say REST APIs, just think it of HTTP, using HTTP, that's all. And HTTPS, because it's more secure. And it is going to use port 440. And gRPC is Google's own way of interacting with the network, right? So how now with it, how a packet is going to look, right? So we have used a similar syntax earlier as well when we talked about how a application data transports between one to the other, be it a email or a web page or whatnot. Now we are talking about the network applications. So again, the header formation will be same. So this data is the application data on which, so this is basically, you can say, your application layer of TCP IP. Then you have your TCP header. So from here to here, it becomes your segment. In TCP header, you'll come to know, okay, if this is 830, the data inside is a netconf data. If this is 440, that means it's some sort of HTTP, and inside because both the applications are familiar of both the ends basically, which are communicating, right? The application, the router that the network application is trying to interact, both the sides know how to interpret the data. They know how to read netconf, restconf, etc. Right? So they know if it is 830, okay, this is going to be netconf. Let me interpret that data in that way. If it is 440 and inside I see some sort of REST queries coming in, I know it is restconf and I'll work accordingly. Right? On top of which we are going to attach the IP header. And here any layer 2 header depending on the media. So if it is Ethernet, it is going to be MAC, right? If it is some other way of layer 2, like some legacy, so could be a frame relay, could be a point-to-point protocol, PPP, something like that, right? So Ethernet will depend on media. IP header, again, if it is IPv6 or IPv4. On top of that, we have TCP that tells, okay, if we have the data for netconf, restconf, or gRPC, and the data itself is governed by two things. First is the rules by which this data is created. So rules are Yang, this is our grammar, and the format. So if I say ROHIT, that means this is my format. So on this interface, both the sides agree that, okay, if the data travels in this format, the network application will be able to send data to the network device or our network device, right? And this can fetch, network application can configure the box. Okay, that is configuration data and can take the state of the network, can understand the state of the network, right? Whether it is functioning properly, whether the configuration that has been applied on the network, the services that have been provisioned of the provisioned on the network are working as expected or not. So these are the three elements basically to form a programmable interface between the device and the application, right? We should have this elementary knowledge because applications, well, as you know, I mean, most of the libraries are already built in, right? If you want to print, give a print statement, that print function is already built for you, right? So similar is there for there's a similar thing for network as well. Most of the functionality is already built by the developers. As a network engineer, what we need to know, we need to know how to consume that libraries that are already built in. So these are the building blocks, right? And for these, many of the libraries are already built in, right? How to use netconf, how to use restconf, how the data is modeled. We need to understand what this data model is, how it looks like, how XML looks like, how we can consume that thing, so that we'll be able to create our own custom applications based on our needs, right? So right, I'll just give a small pause here. Any questions till now?
Yeah, Rohit. So basically, means I have a question. I'm not sure whether other has also has question. So if anybody has question, please do ask. Okay. So what is the means when you say data model? What is the actual meaning of that?
Okay, so Vishnu, there would be two things, right? When I say data model, means we are talking about how to model that data, and it will be more clear in this slide, right? So we are talking about data model.
Okay.
Okay,
Mhm.
so say and this is a very layman example here. I mean, you jump ahead of it.
Oh, okay. No, sorry for that.
I was about to
Sorry for
cover
that.
this thing.
Sorry
No,
for that. Then
that's
basically
perfect.
that's fine.
I
Go with the
expect
flow. Go with the flow.
I would expect this thing from you.
Okay.
Like you would think ahead of it, right? So basically, when we are talking about data model, again, it is modeling the data. So we have different objects in our network, say a VLAN, a interface, a routing protocol, something like that, and there are attributes associated with that, right? And with that attribute, that object is defined. So interface is defined with its IP address, with its status, with its name, etc. And there are rules associated with it. Okay, so the interface name should be the first thing
Yeah.
that should come in an interface description or an interface. I'll use the term description. Then there should be IP address, and these are the rules that govern that IP address. Post that, we can have, say, status of that interface, it's up or down, right? So these are the rules for the status. Then there could be other attributes similar for a person. So for a person, say, the first things first that we should have in defining a person, it is gender, and there are only three options for that. Then there is height, it can be in feet or inches or in meters. So this is how we define a data model. So
Yeah.
if we replace person with the interface and this gender, height, weight, etc. with its attribute, that becomes a data model that is suitable for a network object.
Okay.
Hope that answers.
Yeah.
Perfect. Thank you. So similar to that, we can have data model for interfaces, for routing protocol, etc. Right? And the language that we use here, or the rules of that data, is governed by a language called Yang. Right? So again, say it's English grammar. No, here we have Yang in place that is going to govern the rules, how we are going to structure the interface data. Or basically we need to, I mean, you can understand, right? We need to define a structure on which A end and B end can agree. They are not humans, right? We need to provide a, a, a set of rules to both the parties. the network application and the router, so that they would know, okay, the first information over there is this, the second information over there is this, the third line is this, fourth line is this, something like that, right? So as I said, I mean, this is just a commentary about Yang. So it defines syntax and semantics. It can enforce the rules. So VLAN ID should be between this range. Operational state can be either up or down. I mean, we have industry standard data model like IETF. We have Cisco specific data model. So we'll be taking a few demos wherein you'll be able to understand what we are talking about. So when I say vendor specific, so there are a few features that are supported by, say, just Cisco only, right? So IETF is not going to produce a data model for that. Right? So if we are talk about virtual switching system, I mean, you will come along all these terms when you'll progress in your career with routing and switching. So there are features like that are very specific to Cisco devices. So there are virtual switching system, virtual port channels. So you already know the port channel from this from these sessions, but there is a thing called virtual port channel as well, and that is specific to Cisco Nexus devices. So there's nothing written by IETF or the global standard body for those. So Cisco has to come up with its own data models for these kind of features. Right? Now, what are the elements of Yang? So this is how Yang defines anything. So on top, there is a module. Under that module, there is going to be a container. Then there is going to be a list if required. Otherwise, there is going to be a leaf. And leaf is where the actual data is stored. Right? So this is the entire structure. And this is where the data actually gets stored. Now, how it looks like for a typical interface. I'll take an example, and we have a lot of examples coming in our demos. So this is how a Yang model looks for interface. Okay. So on top, we are telling it's a module that talks about IETF interfaces. That means it is created by the global body. It's not Cisco, and it dictates the rules that should be followed when we are talking about interfaces. There's a container in which we have a lot of interfaces, because we know in a router or switch, we have 1, 2, 5, 48, and in chassis switches, there could be 100 of interfaces. So there is going to be a list in that container. So interfaces is basically a container. In that container, we have a list of interfaces, and each leaf contains a data regarding that interface, right? So a leaf called name is the name of this interface. That means it is like so right now this is just a model, right? How a interface will be created. But when I'm going to fill this data, what I'll do, instead of this thing, I'll put a name, gigabit 1. Rules are here. The type should be string, right? Then there is next data about this interface, that is whether it is enabled or not. So I would put, rather than this, when I put the data for this thing, I'll put a up or down. Okay, by default it's true, means by default it's up. And the rules are here. It is going to be Boolean, 0 or 1. So up, down, say up is 1, 0 is down, something like that. So this is how we define a data model. Now this is very elementary data model. When we'll interact with the actual router, we'll see that I mean, lots and lots of information is there. But you can think, right? If this is building block number 1 for interface, we'll have 1, 2, 3, 4, and so on. Say hundreds of modules, and that creates the entire information of about router, switch, and whatnot. So this is how typically the configuration data or the state data is structured in a form of data model. These are also called, sometimes this is also called the capability of the boxes. Okay, this is what I support. So a router would, a Juniper router cannot support Cisco/interfaces. So that's not its capability. But it can support IETF interface because it is created by a global body. And When something is created by a global body, generally the OEMs or the equipment manufacturers, they do accommodate all those recommendations, right? So with that, let's move to our first demo for the day. And we'll be talking about Yang in this, okay, for this demo. And I'll stop sharing my screen and we'll start sharing the browser. So what we are trying with this demo is, just a moment. Just a moment. Okay, so with this demo, what we are trying to do is we are trying to analyze few of our I'm just bringing up my visual studio. Hope this code editor is visible. The terminal basically.
Yes, Rohit, I can able to see that.
Sure. Thank you, Vishnu. So what we are trying to do with this demo is, first of all, we want to understand like how typically Yang models are written and how we can interpret those, basically understand those. So I'm sharing a web page here that is maintained by you can say a community basically that supports Yang, and in that they keep a record of all the Yang models that are either IETF standard or created by the vendors, etc. Right? So you can see there are experiments draft means there are in development, and fewer RFC means that are finalized. So in this we can see a lot of .yang files available. So all these files talk about how for this particular feature Yang model is structured. Say we just go to IETF. Okay, let's search for interfaces, right? We were talking of it. Okay, so IETF interface Yang. This was the data model that we were talking earlier, right? So if we download this to our machine, one thing, I've already created a copy, a local copy of this. Okay, so that web page was just for reference. And if we navigate to this Yang folder, we'll see the same structure that was there, right? Experimental, standard, vendor, etc. And if we go to standard followed by IETF, there we see RFCs. So again, and what we want to do, we want to grab with anything that says interface, right? So this is the one, IETF interfaces that we took an example, but let's see how it actually looks. So to like explore this, there is a utility called Pyang, Pyang available. Like you can install it using pip install Pyang, that's all. And there are a few options that we need to give. So Pyang, okay, let's first open this directly, how it looks, right? So say cat, what was the name? Sorry. I mean, how these Yang models are written actually. Let's see that thing first. So it will contain all the information about IETF model. That okay, it has got a physical address, it has the last change, etc. But if you want to see it in a more readable way, let's use Pyang with some option. Same IET. And it will present this entire data model in a very readable way, right? So on the top, we have the module, then we have this interfaces container, and then we have first interface, second interface, and you can see that the state data and the configuration data are separated, right? So these are the things, right? If you want to name the interface, okay, it should be a string. The description of the interface, say connection towards R2, R3, connection towards MPLS, connection towards BGP, something like that. What is the type of this interface? Is it available? And these are the rules, okay? It should be a boolean, it should be a string, it should be a enum, like enum means, both, correct? Any character. Then what? Speed. Then the state data. So what is the admin status? Is it up, down, admin down, something like that? So this is how we can explore any Yang file with the help of this Pyang utility. Right? And as I said earlier, all these things are already available to us. We don't need to create any Yang model by ourselves. We can create, obviously, if we want to contribute, but these things are already available. The intent of this session is to make engineers aware about these models, these rules, these data types, these formats, so that these can be used in further automations.
Yeah.
Okay, it's 10:28. Vishnu, how about taking a break now, and post that we can talk about the formats?
Yes, definitely. So basically, right now we have the time is right now 10:28. We can meet at 10:45. Okay, 15 minutes break. Is that
Sure.
fine? Okay, everybody. So we are taking a break of 15 minutes. Let's gather again at 10:45. So I think I can pause the recording, right? Yeah. So I'm resuming the recording. Okay. So thanks everybody, and we are going to start again. Rohit, please take the control. Yeah, go ahead, please.
Thank you, Vishnu. Right, I'll start sharing my presentation again. Okay, so hope my screen is visible.
Yes, your screen is visible.
So thanks Vishnu for confirming. How we can use the Pyang tool to explore the Yang data models, and the Yang catalog basically was the complete catalog that we saw on Git site just before the break. And this is a yangcatalog.org site that it's typically maintained by you can say the Yang authority, and the authority that is responsible for keeping all the data model created in Yang, be it vendor specific or vendor agnostic, IETF models, etc. So with that, we have completed the discussions around the first requirement of this programmatic interface, that is how we model this data, like the rules that is going to govern this data. Now we'll come towards the second point, that is how we are going to format this data. So to format this data, we have got a few options available, and from top to bottom, it's like YAML. That is, as I said, it's most human readable. The second is JSON JavaScript object notation. It's widely used. It is supported by important protocol that is REST-on, basically the HTTP way of interacting with the devices. It's very familiar and human readable if we compare it with XML. And XML is something that is not that user friendly. You can say it's not that human readable. It is a language that takes a lot of effort if you want to read it by open eyes, and we need to take care of a lot of things like namespaces, what is where, how it is structured. So not good for human eyes, but it can be can be understood if with some practice, and it's very easy for the machines to understand basically. So bottom to top, more human readable; top to bottom, more machine readable. As simple as that. Now comparing this with a simple example of how we can create an address for a person called John. So if we want to create this thing in form of XML, XML basically it take use of namespaces. So anything under a defined category is what a namespace is. So name, and again /name is a namespace. In between we provide the information. Then we have a namespace called location. So this is the opening of location and this is the closing of location. Under that we have a city and the state information. So this is how we structure. So XML, this is like not that human readable because a lot of namespaces are there in between when we create the data based on the model that was provided earlier by Yang. Now, if we talk about JSON, you can see it becomes more human readable because it is structured in the format of key value pairs and list. So whenever, if you see anything before a colon, that means it's a key. Anything after that colon is a value for that, and anything in the square brackets is a list, right? So if I'm talking about the user, so user has got some information. So one is its name and its location, and when we talk about its role, so there's a list of roles that user has, that is admin, and it's a user as well. So this is how JSON is written in form of objects, basically key value pairs, that means and very analogous to dictionary, and lists. And when it comes to YAML, YAML is very much like JSON, but instead of using these brackets, YAML uses indentations, right? So anything before colon again is a key, and after the colon is a value. But rather than using opening braces and closing braces to denote any value, it uses indentation, right? So this user has got whatever is indented to the right to this user is information for this particular user, right? So user has a value of this entire thing, and then there are sub values. So there is a dictionary that talks about the name of the user, location of the user, etc. And the value can be a list as well. So dash, anything that starts with a dash is denoted by a list for YAML. So rather than using square brackets, it uses dash, and rather than using curly braces, it uses indentation. So that's the major difference, but that makes it more human readable because we do not have these characters like square bracket, commas, etc. in YAML. While JSON is fits in somewhere in between YAML and the in between of YAML and XML, that it is not that human readable but more readable as compared to the XML. So this is the typical difference, and this is an example of the data about a user. But as we discussed earlier, we can pretty much use the similar thing to uh, denote the data of our routers or switches, be it an operational data or the configuration data, etc. So I'll not take an example right away for JSON, YAML, and XML structure. Rather than that, let's talk about the actual transport. So we have talked about the model, the rules. We have talked about the formats, how we are going to share this data between the two machines, right? So so both the machines now, we are at a stage wherein both the machines knows what is the rule. Okay, these are the ground rules. At first you need to send me this. At the if you want to talk me about this particular thing, say you want to talk me about a routing protocol, first you need to tell me the name of the routing protocol, then probably the, if it is OSPF, then it should be the area number of that protocol, and then the network of that protocol, right? So these would be the rules. Okay, what comes where and in which format, right? So next is how we are going to communicate. Okay, we know we are going to communicate the information about the OSPF. Now how that information should look. Okay, this can look either of these three. Now YAML, since is a newcomer, you can say, in the network world, so not many protocols support it. At least the protocols that we are going to talk about today do not support YAML. So we are going to talk about two transport protocols. One is netconf and one is restconf. We are not going to talk about the gRPC. It's Google's own standard of governing their devices. Basically, they have their own interface to govern their devices. It's a worth reading, but not part of our agenda today. So netconf was like invented in or was were the RFC for netconf came in the year of 2003 or 2005. I am not able to recall the exact year, but it's quite old protocol at that. And at that time, JSON was not that wasn't the dominant language in the web world, right? So so netconf was created on top of XML, and hence it supports XML till date. And that's actually where it's like good. It's the good thing and the bad thing with the netconf. So since it was invented in 2003 2005 era, hence it has got a richer set of application that it can perform on the network, right? The more implementations are there, more support is there for netconf, while for restconf is vice versa. It came into the picture. Let me go to the that section first, and then we can talk about. So um, now we have talked about the two things, modules and the formats. Now how we are going to transport that the data that is formatted in form of JSON or XML, and the rules are governed with Yang. So we are going to talk about two transport protocols here. One is netconf and the other is restconf. Let me grab a pen and we can just do a quick like differentiation between the two. Okay. Just a moment. Somehow I'm not able to move the pen to the second screen. Just allow me a moment.
I think if you need to map it to the second screen. Which pen you are using? Are you using Wacom?
No, not Wacom, it's XP Pen.
Oh, it's XP pen.
Yeah, the options are same. I don't know why it is not getting mapped to the second one. Earlier I was able to, but
Oh, so sometimes there is a problem with the drivers. Even I face this. So
okay.
if I go into the driver setting, not the whatever the program comes with this XP pen, right?
Okay.
It mapped to only one screen, and that is why you
Yeah.
cannot write on the second screen. So sometime it happens. Yeah.
It could be the reason. So I have let me share the other screen in that case.
Yeah.
Okay. I think the whiteboard is visible.
Yeah.
So let's try and come up the think there's some issue with the driver, so let me scribble on the slide itself. That would be better. Don't know what happened to it, but okay. So let me talk verbally then. So let's talk about response first. So or rather, let's talk about netcon first, because it came into the picture in the era of 2000, as I said, 3 somewhere there. So netconf was created as an alternate to SNMP, right? So the SNMP stands for Simple Network Management Protocol, and it works on a legacy way of managing networks that is called OIDs, or Object Identifier, basically. And the intent was just to replace that thing, but it had a good support when it comes to the modeling and the formatting of data in form of XML. So it created basically a ground for the automation engineer to come up with a network application that can automate network provisioning, network services, etc. With the help of this netconf transport protocol. It uses protocol or TCP port number 830, and it supports only one formatting language out of the three that we talked about. So we talked about YAML, XML, and JSON. Netconf only supports XML, and that's a limitation with this protocol. How netconf works? Basically, there are a few libraries that are built in with Python. One of these are called NC client, so netconf client. With the help of netconf client, we can check first of all the capability of the box. So say I want to understand before establishing a netconf session, I want to understand, okay, what kind of modules do you support? When I say modules, that what kind of data models you support, right? Hey box. What I'll do, my application is here. This is my network application that is there to configure a network infra. So if this is network infra, a router or a switch or anything. So if this application wants to understand, okay, that if I want to automate anything for this box, be it a network provisioning or network services, I first of all need to understand what capability this box has got. When I say capability, what kind of network models it supports, right? The Yang models it supports. So with that, I'll be able to understand, okay, if you support these things, I'll be able to automate your provisioning with the use of the capabilities that you shared with me. So the first message that netconf is going to send, okay, share me your capabilities. In return, this box is going to tell, okay, I support these many standard body protocols or these many standard body modules, not the protocol, be it IETF, say IETF interface was the thing that we talked about. So it will say, okay, I support IETF interfaces, right? And there are other IETF as well, be it related to BFD, BGP, OSPF, something. And since I am a Cisco box, I support VSS module, I support VPC, and so on and so forth. So this network application now knows, okay, this box supports these many Yang modules, and hence I can communicate if I want to configure these services related to these module with this box, right? So if it supports VSS, that means I can create a message in form of XML, in XML format, that is going to follow VSS Yang model. Okay, so suppose VSS Yang model says there should be 5 namespaces, right? 1, 2, 3, 4, 5, something like that. And in each namespace there should be some information. Say first information is what is the virtual switch link. Okay, so could be some interface, right? Then what should be the keep alive timer, right? Between the two links. Keep alive means a heartbeat. Okay, you are alive, I am alive, something like that. They are checking each other. Okay, so something like that. So now this application understands that, okay, if I want to create a VSS service on this R1 box, I can send data in the Yang model defined for VSS and in XML format. It will send that data with the netconf transport protocol. Okay, so there is going to be data, first of all, this network application data, in which it is saying configure VSS. Right, under that, this is going to be encapsulated in a TCP with port number 83. On top of that, we'll have IP, layer 2 header, and then it will send on the wire in form of 10s. Right, so this is how this communication will take place. In return, this router can reply back saying that, okay, this thing is configured, something like yes, no, whatever netconf protocol says, right? So this is how typically netconf works. For RESTconf, because it came into the picture like in 2016 or 17, it is a newer protocol as compared to netconf, so it supports JSON, and that's a good advantage that we get, that makes this protocol more user friendly, right? As we saw, that JSON is more human readable. Second thing, it is called REST conf, right? Why? Because it follows a typical application term, that is representational state transfer, right? That is the full form of REST. This is nothing but it is not going to create a separate protocol stack for itself, but rather use the existing HTTPS stack, right? So we already have a good protocol, HTTP, right? That is the protocol of the World Wide Web. With this protocol, several applications are working over the web, right? So anything, right? Facebook, Google, Microsoft Online, all these are using HTTPS. Our Cisco's WWN web page, I mean, any kind of web page uses this service, right? So we already have a good protocol that can be used to establish the communication. And if we are using a protocol that is already there in place, first of all, we are not wasting our efforts in reinventing the wheel, right? We already have the rules for the protocol. Second thing, the development or the integration with the other applications would be faster, because right now netconf is known to network world, but it is not known to the web developers. Well, if we are using that is known to web developers in our networks, that means the application that will be built using RESTconf for network, that can easily interact with the other application. And when I say that, say Facebook is built with HTTP, it knows how HTTP work. Now, if my network application is also built with HTTP, it also follow the rules of HTTP. That means these two can interact with each other easily. So Facebook can interact directly with network application, and it can tell network application, okay, hey network, I am facing slowness. Please create something for me, some more bandwidth for me, something like that, right? So we get that kind of flexibility, that kind of opportunity with netconf. Okay, so now we'll I mean, just an explanation of what we already saw, that okay, the RESTconf uses the HTTP. In HTTP, we have got these typical ways of interacting. So we can get the information, we can put, post and patch. So basically we can update the data, provide the data and append the data, and we can delete the existing data. So in terms of networking, we can say gather the operational data, interface status, routing status, BGP status, something like that. Put, post, patch means applying the configurations. Remove and delete means removing the existing configuration. Right, so this is how RESTconf will work, because it is going to follow the typical HTTP request types. Now let's move to a few examples of RESTconf. So I have a Postman session in the lab. Just a moment. And with that, I think we'll be able to get a better understanding of how RESTconf works. Allow me a moment. Before that, I just want to understand, are there any questions regarding the things we talked about so far? What is model? What is format? What is the transport? Why we are using this transport? Why we need transport basically?
Rohit, I have one question. So, if I've understood correctly, that that whatever the data models, or let's say Yang, XML, JSON, so that will be, that should be something compatible with the protocol, and that's how we send it. So the protocol is nothing, it's just a way to communicate the way we have, like, in BGP and all, and the main purpose is to send that information via that data models, or I mean whatever you just explained, correct? It's JSON and XML.
Yes, Punish, your understanding is absolutely right. With netconf and restconf, these are the two transport protocols typically used for network applications. So yes, the whole sole purpose is to transport the application between the two parties, the application, the network application, and the box that is under the management of that application.
Okay, thanks.
All right. So, guys, what I'm sharing right now is the lab that been created to showcase. This looks a bit complex, but right now what we are doing, we are just trying to manage this box, CSR, right, with the help of RESTconf. So as we said earlier in RESTconf, that the RESTconf is typically the RESTconf typically uses well-defined HTTPS structure, right? So what we'll do, we'll use the GET request that is very common with right. So same are the rules with RESTconf to manage any device. So the first example that I'll be taking here is XC capabilities. Why I'm saying it as XC capabilities, because the box that is here, it is running XC software. So if you here are the properties, or if you click nodes here, you can see, okay, what software these boxes are running. So this CSR particularly in particular is running 1696 Fuji image, right? So it's an XC box, and hence I'm calling it as XC capabilities. Initially, for now, so I have already ran this query, but we'll be running it again. So what we are trying to do, we are interacting with this XC in this way, there is a REST-con documentation available for XC boxes, basically, you can say. Okay, so what is API documentation, right? So say it's API documentation is not limited to networks, right? So if you say Twitter API documentation, right? So they'll clearly give you, okay, this is how the Twitter query should be written. Okay, so if you scroll down, they'll tell you, okay, if you want to access Twitter, these should be, I mean, this is not a good example, but maybe this page they can give, okay, yes, like this, okay. If you want to run a GET request, do this. If you want to run a post request, do this, right? How you can get the likes, how you can manage the tweets. So this is how typically every application owner provides you a API documentation. Same is the case with Cisco IOS XE, right? There is a rich documentation regarding the APIs and how you should structure the APIs. So from there, we get that if we want to know the capabilities of a box, of a XE box, what query should we run? So this is how we should run the query. And you can already see the effect of netcon because it came into the picture. Earlier before restcon, though we are running a restcon query, netconf is still there because it was used to create the object model in iOS XE, right? It's not a netcon query, it's a restcon query. So what we are doing, we are logging onto the box with restconf and asking for query. So how we'll do it? We'll just create this. We'll add the user credentials. So admin are the user and password. And in box, it is going to send the request, and these are the query that it fetched. These are the capabilities that and you can see, right? It's huge. I mean, it supports IPv4 unicast routing, then OSPF, then there are open config related things, then there's AAA, ACL. I mean, every feature of this box, for every feature of this box, we have a Yang model in place. So this is how we can configure each and every feature that is present. So if we want to configure a cellular model of cellular interface on this box, say it's running of 3G or 4G interface, right? So we can configure that. If we want to run crypto, we want to encrypt the communication between this box to the other boxes, we can utilize that model. So once we know the model, we now we want to know the exact specification for that, right? So again, I'll take an example and say we want to check how the interface, this model is formatted, right? So earlier we talked about IETF interfaces. Now let's see how Cisco has formatted or how Cisco has written the Yang code for its interfaces. What informations are there in Cisco's way of creating interface? So if I query this box, okay, tell me how the interface should be created or what data would I get from the interfaces. So these are the things that a typical interface would have, right? So it will tell me, okay, how many unicast packets in input, broadcast packets input, broadcast packet output, right? What are the errors on any of the interfaces? What is the receive rates per packet per second? What is the receive kilobits per second? Transmit packets per second? Transmit kilobits per second? CRC errors, etc. Right? And then we can have VRF related informations. Okay, basically VRF is kind of network segmentation at layer 3. So you learned about VLAN, that is network segmentation at layer 2. This VRF is basically network segmentation at layer 3. So this is how Cisco has constructed its interface data. Why? Because Cisco says, okay, IETF has got this many, but I have a lot more features to offer to its user. So let me construct it in my own way. right? So this is about all the interfaces. Now say I just want to talk about only one interface, right? Say it is giving me gigabit interface Ethernet 1, then it will give me gigabit Ethernet 2, 3, 4, something like that. Now I just want to talk about check only one interface. What is the status of that particular interface? So what I'll do, I'll run this get query for that particular interface. How to format it? We need to read the API documentation. Okay. So same parameters, I'll authorize my query with the user credential. In the header, I'll say, okay, provide me the data in form of JSON because that is more readable and that's the benefit that I get from using RESTconf. Okay, let me send this query to the box and it will provide me information specific to this interface. So we know that we are using .148 IP. So here is that info that this box is managed on this IP. Okay, not only the get, that means the operational data, we can post the data as well. So here I am taking an example wherein we'll be creating a loopback interface on this box using our RESTconf protocol. Here we can do this by manual way as well, right? Log into the box with SSH, provide user credential, do an interface loopback something and give the IP. Now the same thing how we can do with the help of automation. So with data model of IETF interface, I know that if I want to create an interface, I need to provide this information, the name of the information, description of the information, its type, should it be up or down, and its address. Having that in mind, I'll create a format, a JSON format for this creation request, right? This data will be sent along with few HTTP headers. So one is I am sending the data in form of JSON. The second important thing is these user credentials. So what this query will do, and we can see right now, if you log in here, right on this box, there's no loopback 0 created, right? So if I send this query to the box, this is a post request. Because this is RESTconf, you won't see that we are using RESTconf, we are using just the get and post in typical Postman typical HTTP format, right? And that's the beauty of this protocol. Written specifically for RESTconf. This is just the data model that is present on that box. We are running the HTTPS queries. That's all. Get, post, put, all those things, right? Nothing specific with which you can say, okay, no, something alien is there that is not known to HTTPS. Okay, and because of that, a typical web application will not be able to interact with our application. So again, coming back to the demo, the loopback interface is not there. If you want to create it, create our query, send it to the box, and let's see what happens. So it says, okay, this 102 management station logged into the box. It created a loopback 600 and the status is up. So if I check the status again, the loopback is created here with the information that was provided in the HTTP body. So we said that create a loopback 600 with this IP and this subnet mask. Now, so this is how we can use RESTconf to automate the different network tasks, the routine network tasks. Coming back to netconf now. So let me bring the presentation again.
Hey Rohit, yep. Just one query on that Postman application, right, that we are using. So it is specifically for APIs, right? I mean, or for any other purpose also we still use it
We test APIs
using this.
and that to HTTP.
Okay. And the this different this parents and authorization and headers. So
Mhm.
depending upon the query, this will vary, right? Or there is any fix, that you need to use this, options when you do get and this option when you do post. So are there any mandatory fields that we need to, like suppose for get, which are all fields we need to use from these options?
Gen
So
these
this
are the two.
with
Mhm.
each get query, we need to update this, right? What is expected from the device and what device should expect as a query.
Yes, yes.
Okay.
For basic queries, right? And I mean, there are options in Postman. If we do a deep dive, there are options wherein we can group our queries. So rather than writing these variables in each and every query, we can create a hierarchy. Okay, if I put all these in a group, and I say for all these query, you need to use these variables
Okay.
here. Okay, so now all these 6 queries are going to use those variables.
Okay.
This way we can group our queries.
Okay. Yeah. Thanks.
And one more question. So the application which you're using it, to this post get, is it? I'm sorry if I missed that. I'm not sure. What application is this?
This is Postman. Okay,
Oh, okay.
this is Postman.
Understood. Okay. Thanks.
Sorry guys, if I missed the introduction. So this is a typical way to test our HTTP query. So it's not limited to uh, uh, this, I mean, network, right? Say if I want to create a new one, not new collection, but what say add a request, and I can just do a get https www.google.com. Let's see how, I mean, at least it is going to interact, though we may not get a proper reply, but yes, so this way it it landed onto google.com, and this is the actual coding of the web page that you see. Right, so the entire Google web page, this is the XML coding of that web page that we are receiving. So this Postman is a typical way to test any HTTP request, reply, etc. So since we are using RESTconf here, we are utilizing a pre-built tool that is already present, and we are using for our purpose, because we already have REST API open at the other end. It's a common interface between the XE box and Postman. Postman understands REST API as well as XE box because it has given us these capabilities, right? So
Okay. So if I've understood correctly, so once we have this application and if you're able to communicate successfully with the, let's say, with the iOS XE device, then it will automatically give us that these are the options or the things which you can do with this.
yes.
Correct.
So yes, these are the capabilities. So I mean, it's difficult to read, but if we open all these, we'll be able to understand. Okay, this is how the model is structured, and how to utilize that model. Yes.
Great.
This is great, actually. So I was just
I have
thinking
one
that
doubt in
I
this.
have taken an example of Postman in my first class, which was delivering the letters, right? But here, this Postman is understanding so many things like REST APIs. Thank you so much, Rohit, for that. Yeah, go ahead. Who was asking question? Please go ahead.
Yeah, I have one question. Like when we are using Postman, we basically like give some routes in while you are fetching any data, whether it is get or post. So
Mhm.
in this networking, how can we find some particular route? Like we have given HTTPS 173.16.1. Like how can we select this? Because in backend API, making
Mhm.
backend API, we are having some routes. So how can we select here?
Hemant, I need to check the documentation, right? For every information that we need to check, right? So we know the CLI, right? That's why we know show IP route is the command to check a route on a CLI. Now, if I want to get the similar information with this query, I need to check the documentation where it comes in this structure. You're getting my point, right? I'll not be able to show it right away because I.
Yeah, it is basically similar to while when we are making backend API request. It is just
Yes.
similar, right?
Yes, it is similar. It is similar, and out of these, I mean, these are the capabilities, right? We need to utilize one of these capability. So there should be some capability that would have routes in it. The name of routes, right? You can see right here it has got interface, it has got interface operations, IPv6, IPSLA. So there is going to be a similar capabilities that says route, and we need to check the document for that capability, and we can build a query with that capability, and we can see in the reply that we are getting the information about the route.
Okay, got it.
So
And,
I think Rohit, like from Hemant's question, right? So the path that we give, right, in this query, like HTTPS, then the IP address of the device through which we can access the device, right? Then RESTconf and data. So few of the fields like till data or netconf state will be standard, right? And thereafter, whatever we want to get or post, those particular paths we need to append to this particular whole URL per se.
yes, that's
Okay.
absolutely right. Yes.
So this is Hemant. So this is the standard format for any query, right? That you would use to get or post, right? So the starting would be HTTPS, then the IP address of the device, right? Then the RESTconf and data, and so this is how you create the whole URL to fetch or post any details.
Okay, thank you.
Yeah, please proceed, Rohit. Thanks.
Thank you. Right. So this was all about RESTconf, basically a really basic introduction to RESTconf, very basic capabilities. And Hemant, good that you asked that question. So with this knowledge only, we can build upon our specific requirements, right? We can build application on our specific requirements. So Hemant, as you said, if we want to identify a route, how should we write it? Okay, there is going to be a HTTP query for that. There could be some other thing that we need to fetch from the boxes. According to that, we need to build our applications and the respective HTTP queries. So thanks for the question. Okay, with this, let's move towards netconf. That is also very similar to what we saw in RESTconf. Just the application would be different because netconf is not built on top of HTTP, so we'll not be able to use Postman here. Rather, there is a library called NC client. That's a Python library, and that can be leveraged for netconf. Okay, so first of all, let's talk about a few features of netconf, and then we'll again go towards a similar demo. So netconf, it's a little different from what we see in RESTconf. So it has got its own way of managing the box. So rather than having get, push, post, put messages, it has its own set of messages because it's a separate protocol. Right? In RESTconf, we were using HTTP's own set of messages. But here, because it is more specific to networks, it has got get config, get request, copy config, log config, etc. So mostly we'll be using get config in our demos. But yes, we can do the similar activities that we did with RESTconf. So we can edit the config, we can delete the config, close the session, copy the config, etc. This is just the description, the high-level description of how this protocol works. It works on port number 830, and this is a separate slide. So yes, so moving towards the demo for netconf, nothing too flashy about it. Just the client would be different. Here we are not going to use Postman, but rather we'll be using NC client, that is netconf client library that is built for this particular purpose. So let me. Okay, so I have created only two files here. One is to again fetch the capabilities of the box. Called connect to the box. This will use few arguments like what is the IP of the box, what is the port of the box, user credentials, all those options that we gave in RESTconf. And then we just want to print the capabilities. So m.server capabilities are basically the capabilities that the box is going to provide us with some formatting. So this star formatting is just to beautify the output, because generally on CLI the output that we get is a bit clumsy and difficult to read. So this is just for formatting, nothing else, right? So if I run this with Python, we can expect a similar output that we got in RESTconf capability query. Right, so it's quite similar. So these are all the Yang models that are supported by that box. Same information, just the transport. Say we want to check the routing current configuration of the box. Okay, so netconf get. So this get config, m.get config, this is we saw that in those messages, right? That get config is a message that can be sent to the box that will provide us the running config of the box in form of XML, because netconf supports XML only, not the JSON. And this again are the formatting options, right? So we can see the output in a prettier format. So what we are doing, we are establishing a connection with the box with NC client, that is netconf client. We are providing the information, port IP, port number, user credential. Host key false is we'll just avoid checking the these SSH keys login. Okay, so if I run this thing using Python, we'll be getting the running config of the box in the format that netconf support, that is XML format. Yep. So this is basically the entire running configuration. It's written in XML, that's why it's difficult to read. But any machine will be able to understand it easily, right? So if this is we supply it to any machine code, that will be able to easily interpret rather than us humans. So a machine will be able to easily see that, okay, this is the namespace for versions, so that this is running 16, something like this. Then what is the host name? So this is the namespace for host name, and so on and so forth. So this is how netconf works. And yep, once we have the information, running config information, we can build our application on top of it, because we know what is where. So yeah, this was the typical introduction of how we interact with the boxes in automated manner. So what we need, how we can build small application, how we can build complex application on top of it. So yep, that would be it from my end.
That is great. That is great, Rohit, and thank you so much. Anybody has any question, please do ask. This is the time.
One
And
question I have. So
yeah, go ahead.
this file I believe you have created, correct? That's netconf.get.py file.
Yes.
Hmm.
This file is.
Okay. So it supports XML. Yeah, makes sense.
Yeah, it will support only XML. Netcon can't get JSON.
Okay. Because why it clicked to my mind. Even our in our Viptela SD environment, we enable this netconf on the interfaces,
Yes.
right?
Yes.
So it looks like that it supports only netconf in that case, our Viptela. Okay.
Oh no, for Viptela, southbound, okay, so there is a concept that I skipped actually. There are two types of APIs, southbound API and northbound APIs.
Mhm.
So for that, let me bring in the Viptela setup quickly. So Vishnu, I'll just take 5 more minutes. It
No
could
problems.
be
No
not that
problems.
relevant, but
No
but
problems.
just so okay. So guys, this is a bit like advanced concept wherein we are managing our network with the help of controllers. So what we are doing, we are separating the data plane and the control plane of the network. And what I mean by data plane and control plane, typically what we do is if there is a router in the network or a switch in the network, it is serving both the purpose of data and the control plane. What is data? That is flowing in the network, right? The actual application data. Say you are opening a web page, so that web page is a data, right? That would flow from here to here to here to here, right? And the control plane is that governs the flow of the data, right? So if the data wants to reach from this point to this point, the entire network needs to govern that flow, right? How to reach from this IP to this IP. So this router would know, okay, you want to go to this, your next stop is this. You want to go to this, your next stop is this, something like that. And that information is called the control plane information. So with the software defined era, what we are doing, we are making these boxes, that are carrying the data, basically limited to data functionality, and the control plane functionality will be governed by a control plane separated from this data plane, right? So the data would still flow from these boxes, but the control information, okay, what should be the next stop for this would be governed by this control plane. Okay, these are fancy pink blue boxes, right? These are vManage, vSmart, vBond. I mean, they have got their separate functionalities, but basically how to govern the data flow is separated from the actual data network, right? So now if we want to manage this control plane through API, then there are two directions to manage. One is the application that will be coming, say my application is here, right? My network application is here and it is going to talk to this control plane box. So that becomes a northbound API for this, means coming from upside. And if this box, this management plane or the control plane box wants to manage a device in this data plane, that means it needs to talk southbound below to it. So that becomes a southbound API. So to Punish's question, the northbound API here, the application to vManage talk will generally happen in the form of RESTconf or the HTTP, because this vManage is actually running in HTTP. While we talk from vManage to this, to the southbound boxes, to these devices, right, to the data plane devices, that thing will be in form of netconf.
Great.
Yeah.
And for others, do not worry about that if you do not get what these colorful boxes are, or what is the meaning of control plane and data plane. Do not worry about it. You have just joined Cisco maybe 15, 20, 30 days back. So there is so many ample of opportunities are going to be there for you to learn all these things. And we will be covering control plane and data plane in next 2 sessions, maybe tomorrow and day after tomorrow. So do not worry about it. And the network which Rohit is showing you, it is the most advanced network of current generation, where we are using software-defined networking to control the data, as mentioned by Rohit. And do not worry if you know the fundamentals of networking well, like OSPF, BGP, MPLS, and whatever we are reading here. Understanding this network is going to be piece of cake for you, but build that solid base, solid fundamentals, because most of the network engineers struggle in software-defined networking because they do not have the fundamental right? So everybody, there is a request, just take this course seriously, right? So that in coming future, when you're going to face the customer, when you get selected in Cisco, when you're permanent employee here, right? And you are going to face the customers. I really want that you should have a solid base so that you can at least understand what he's saying, and you can advise, you can consult them that what to do so that their network can be improved. Having said that, we are meeting in next 15 minutes. Rohit, do we have anything else to cover, or are we done from your point of view?
No, Vishnu, from my end.
Perfect. So 15 minutes later, Anumol is going to give us the introduction towards wireless technologies. It is going to be the interesting session. See you in 15 minutes, exactly at 12 p.m. Bye for now. And thank you so much, Rohit, for taking this 2 hours lecture here so that we all come to know about that how programming and its programmability can ease our life. It should be with every network engineer, because I can see that in upcoming time, if we do not know all these things, automation, programmability, we are going to be literally illiterate in the field of computer science. Okay. And thank you so much, Rohit, for talking about the automation and programmability.
Thanks, Vishnu, for the opportunity.
Yeah.
Appreciate it.
See you in 15 minutes. I'm stopping the recording for now. Pausing the recording. Resume. So thank you so much, Anumol, for joining. And there is a session in there is a particular section in CCNA which talks about wireless, and we are pretty bad with respect to wireless technologies. And I know that you have been doing a great work in this field. So we thought to invite you in this session so that everybody can get a little bit understanding of what we are doing in wireless technology. And thank you so much, Anumol, for joining this session. Now it's all up to you. Thanks once again. Please go ahead.
Plays an important role in this particular enterprise deployments. So I'll just give a quick introduction of myself and then we can get started. So my name is Anumol Shashi. I work as a consulting engineer with the enterprise wireless team. I was also someone who joined straight out of college as an EIC. So yeah, I remember sitting on the other side of the table. But and I hope this session proves useful to every one of you guys. Before I start, one thing is feel free to interrupt me in case you have any questions. I'll try to answer them to the best of my knowledge. But just in case you do not have any questions, you can go back, read through the slides, read through books. I'm available on Teams, so you can ping me if it's something that we can sort on the Teams. We can do that, or else I'm okay to get on a WebEx call and get things sorted. So that's a note that I want to start with. So in this session, what I'll try to do is I'll try to give a very brief view of the wireless basics, things that will actually help you lay down some foundation to start building on with this technology. I hope everyone can hear me out loud and clear, right? There's no disturbance or anything.
No disturbance anymore. You are loud and clear.
Okay. Thank you, Vishnu. Yeah. So that's how the agenda for the next 1 hour is going to be. We will have a look at first how wireless has evolved over these years. We'll then look at some RF fundamentals, radio frequency fundamentals, on which this entire technology is actually built. We will then go on to understand the different wireless components and then link it to the wireless architecture. And finally, if time permits, I will give a short demo, especially on the WLC part, just so that you guys get an idea about the look and feel and what all are the different things that are actually present on a WLC. So I found this meme to be a good starting point. It's a nice pictorial representation of going wireless. However, over here, they are surprised that the other guy has Wi-Fi, but I think for our generation at least, we would probably be surprised if someone has not heard or used Wi-Fi. So yeah, things have changed and we are soon going Wi-Fi first. So that's the point to start with. Before going into wireless, let's try understand a bit about how wireless has evolved, what's the starting point, and what's the history behind this particular technology. So WLAN technology has a very long history that actually starts from somewhere in 1970s, wherein it was the University of Hawaii who first developed the first wireless network, which they called as AlohaNet. And they basically developed this wireless network so that they could communicate data wirelessly between different Hawaiian islands. And then later in 1990s, different vendors basically picked up this particular network and they started to produce low speed wireless products. And then in 1997, IEEE ratified the original 802.11 standard, which is the wireless technology standard. And between 1997 and 1999, this technology got to be used in warehouses and manufacturing environments. And when they started using this technology, that's when they felt that, there's amendments that needs to be done. Like we need higher data rates, we need better bandwidth, better throughputs. And then from the year 1999, IEEE gotten different amendments with different visions. Like for example, in the year 1999, 802.11b was born, which basically defined higher speeds as compared to the original .11 amendment. And so on in the years, higher speeds, better throughputs were defined. And right now, yeah, we have good Wi-Fi speed, good bandwidth. So that's where we are today. Now, this slide will actually give us a fair idea with respect to what are the different organizations that are associated with different aspects of the wireless industry. So the first two organizations that you see, which is ITUR and FCC, these two are the organization which basically sets rules with respect to what can be done with a radio transmitter. Like for example, they manage and regulate the kind of frequencies that we have to use, the power levels which we have to transmit, so on. So all these parameters are basically defined or taken care by these two organizations. The next one is IEEE, which I think most of us over here are familiar with. So in wireless especially, IEEE is responsible for creation of standards, which basically deals with compatibility, coexisting with different networking equipments. The next one, which is IETF, which is Internet Engineering Task Force, the name itself says it's actually responsible for creating internet standards. Let's keep Wi-Fi Alliance out for now. The other organizations that you see under region specific, they're basically regional organizations tied up with specific regions who manage and control Wi-Fi standards within each region. For example, you have one organization for Asia, Australia, you have one for Africa, one for Europe, and so on. So these are organizations which are region specific. Now, there's a different organization called as Wi-Fi Alliance, which actually deals with certificate testing. So every Wi-Fi device that comes out in the market needs to have a certificate from the Wi-Fi Alliance, and only after the certification is done that you can actually use that product. So what Wi-Fi Alliance does is, whenever a vendor puts out a new product in the market, they basically test that particular device just to ensure that the device meets all the standards that IEEE has set in the 802.11. So only when the device meets all those standards, that Wi-Fi Alliance gives it a Go certificate, and after the certificate, it's out in the market to be basically used by both enterprise or even for home as well. So that's the main organizations where Wi-Fi is actually coming into picture. Okay. Now, when I discussed about the history of wireless in the first slide, I mentioned how after 1999, people realized that we need better capabilities in wireless, and hence what I can say is amendments need to be done, right? So after 1999, if you go to see, there are a lot of amendments that IEEE has basically come out with. And IEEE has defined these amendments for better speeds, for better throughputs, etc. So this slide covers the different amendments that's happened in wireless over a period of time. So for example, 802.11, that's the original parent IEEE standard, which provides for local area networking using RF. So in simple terms, if someone comes over and asks you what is the IEEE standard for wireless, it's 802.11. And if you see on the slide, you have a letter which is associated with 11, right? 11B, 11G, AG, N, AC. So each letter which gets associated to .11 means a new amendment, and each of these amendments were basically defined to achieve a specific purpose. Like for example, the first amendment .B defined how to achieve higher data rates within the 2.4 gigahertz band. The next amendment, which is G, it was all about achieving greater bandwidth, and so on. So you can actually go on and read about these amendments in depth. They are basically available both in your CCNA book as well as even on Google under IEEE site. So you can go about and read as to what all these amendments are about and what did they try to achieve, just to get a holistic view of what has happened over a period of time. But the latest that we have is AX. Even Cisco has released AX access points getting compatible with this particular amendment, where what it focused is on extended Wi-Fi outdoor range. And it's very, very efficient in high density environments. Like for example, when we go on to do a Wi-Fi deployment in a stadium or in a huge university where it's an outdoor range and there are a lot of people that's gonna gather, then this particular .11 AX is very, very efficient. So that's what AX APs tried to achieve. I think we have set a context, a good introduction to basically start with. So we'll take a step deeper into RF or radio frequency. And this is actually the foundation stone for this particular technology. So you understand RF, you are halfway through the wireless. Okay. So this particular spectrum is something I believe all of us have seen right from our school days. It's from the science textbook. It's something called as an electromagnetic or an EM wave. But for people who don't recollect it, I'll just explain in simple terms. Your electromagnetic or your EM spectrum is actually a range of different types of EM radiations, like you have your X-rays, you have your gamma, UV rays, and so on. Now, from your wireless technology perspective, there's a section of this spectrum that's very, very important to us, and that's called as the radio waves, which I've actually highlighted in the red box that you can see. So in layman terms, if you want to understand this, imagine something like this. An AC current is getting developed or generated by your transmitter, which actually goes to your antenna via a cable medium. And from the antenna, it gets radiated out in the form of a EM wave or a radio wave, which is actually your wireless signal. And that EM wave basically fits into this radio wave section. So this signal, whenever the signal or this wave, whenever it radiates, it basically has some properties as well as some behaviors that are associated to it. Can someone unmute and, maybe list out what are the different properties or characteristics that you have studied about a normal wave? Anyone?
Okay, so basically it has some amplitude, frequency, and those are the things. But this is my curiosity that how basically we are sending because it is very understandable in the form of wire, right? When we send signals, then basically we are sending the electric current. Maybe sometime it is a higher voltage and sometime it is at a lower voltage. So I can represent ones and zero. But this is pretty amazing to send all these things over the air also in the form of this wave.
Yes.
So I haven't done much reading with respect to wireless, but yes, I know that there was some amplitude, frequency, and yes, everything is there now in this slide.
Yes, perfect, Vishnu. That's the answer. So whenever the wave comes out or whenever the signal comes out of an antenna, there are 4 characteristics that would actually define that EM wave, which is your wavelength, your frequency, your phase, and your amplitude. You will realize the importance of these characteristics when we speak more about the behaviors that RF will have. So if I have to describe all these 4 characteristics, starting with wavelength, wavelength is actually distance between 2 successive peaks. If you don't like peaks, you can take it as 2 successive troughs. So that's what wavelength is all about. Frequency in simple terms is the number of times an RF signal or an RF signal cycles in actually 1 second. Coming to phase, phase is a special characteristics because like when I discussed wavelength and frequency, it was only with respect to one signal. But phase, you always compare it as between 2 signals. So there are 2 concepts in phase, something called as in phase and out of phase. In phase is when 2 signals that you receive are similar or basically both signals are in alignment. That is when you say it is an in phase signal. Whereas an out of phase signal is when the peaks or the troughs are not in alignment. Like for example, if you see the 90 degrees out of signal or the 180 degrees out of signal, it does not coincide with the peak of the main signal. And where this is important is, let's say if you receive the main signal and an 180 degree out of phase signal, and when you have to add these 2 signals together, the net result would actually be 0. So that's how important phase is in Wi-Fi signals. And amplitude is basically how loud or how strong your signal is. That's what amplitude is about. Now, like I was saying, as your waves or your signals travel over the air, they showcase different behaviors depending upon the environment in which they are subjected to. Like, for example, they face absorption, wherein whenever a signal travels from one material to another material, some amount is basically absorbed by this material. And this is actually true even for your Wi-Fi signal. So when you're sitting inside a room, the signal strength that you get inside the room versus outside the room would be different because the door or the glass door or even your brick walls, they will absorb some signal strength. That's where absorption comes into picture. Reflection is when your signal gets bounced off in a different direction. And scattering is very similar to reflection, but scattering is multiple reflections that is happening at a given time. If I have to explain diffraction, this is something I always remember. So imagine a flowing river, and then you keep a huge rock in the middle of that river. So the river cannot cut the rock, it will not go over the rock, but what it will do is it will mend itself in such a way that it will go, alongside the rock, like it will bend itself and make its way. That is how a signal also behaves with respect to some materials. It will not get absorbed by that material or reflected by that material, but then it will bend itself around that material and make its way. So that's where diffraction comes into picture. Loss is actually very, very similar to what happens in absorption. So like I was saying, right, the signal strength outside the room and inside the room would be different, because some portion of the signal would be absorbed by your door or by your wall. So the signal that you get post that absorption is basically less than what was outside. So there's a loss that has happened, and that is what loss as a behavior talks about over here. Multipath is actually an extension of reflection. So whenever a main signal comes out, because of multiple things in that environment, it can get reflected. So a single signal can get reflected into multiple signals, and your receiving antenna can basically get multiple variants of that same signal, and that's when multipath comes into picture. Now, multipath again has different sub behaviors. Like for example, there's a behavior called as up fade, wherein both the main signal and the reflected signals are arriving at the same time. What will happen is, because they are arriving at the same time, their peaks are all in alignment, the net signal would actually be an enhanced one. So it's actually good for your Wi-Fi. But then there's also a scenario wherein it's called as down fade, wherein your main signal and the reflected signals are all coming out of phase, because of which you will have a reduced amplitude, which is not good. Then you have a third case called as nulling, wherein your main signal and your... Sorry, someone had a question? Okay. Yeah, so I was talking about nulling, wherein your main signal and your reflected signals are 180 degrees out of phase, so there's no net signal at the end. And then there's a fourth case called as data corruption, wherein your main signal and your reflected signals have arrived in such a position such that whenever the receiving antenna demodulates your data, it's not able to demodulate it properly, and hence your data gets corrupted. So that's what data corruption in multipath speaks about. Okay. Now I believe all of you will be thinking, what does all these have to do with wireless, right? We spoke about amplitude, we spoke about different behaviors, but how does this affect wireless as such? So when we as consulting engineers go to a customer deployment to maybe deploy or design a wireless setup, we need to take into consideration the environment that they have, the properties, the behavior that they would actually showcase, because all these will have a direct role on your Wi-Fi signal. So we'll have to design in such a way that effective Wi-Fi signal that you obtain is strong enough and it actually meets your customer requirements. So for all this, it's very important that we understand how absorption takes place, how to basically avoid such a use case. So that's where all these fundamentals comes into picture. Now we'll try and understand the different bands on which Wi-Fi works on. So your Wi-Fi predominantly works on two bands, which is 2.4 gigahertz and 5 gigahertz. So I'll first cover the 2.4 gigahertz part first, and then we'll move to the 5. So 2.4 gigahertz is right now a very legacy band where you have legacy devices being operated. The newer devices that are coming into the picture are basically opting more for 5 gigahertz band. And you will also understand the reason why when I explain 5 after 2.4. So your 2.4, like you can see on this slide, it is actually divided into 14 channels, and each channel is designated or is basically called out by its center frequency. So if I have to say the channel 1 frequency, I would actually say it's 2.410 gigahertz. So that's how it is identified. And each channel here basically has a width of 22 megahertz. Now, there are two things that you can actually see in this particular diagram. One thing is how the channels are basically laid out in the 2.4 gigahertz. And if you observe closely, you will also see channel overlapping that is happening, right? For example, if you look at channel 1 and if you look at 2, 3, 4, and 5, they share some space with each other. So basically, channel 1 is overlapping with 2, 3, 4, and 5. So imagine something like this. Channel 1 and channel 2 are basically two people sitting very, very close to each other and then taking a meeting. What would happen? Whatever person 1 is talking will be heard by person 2, and whatever person 2 is talking will be heard by person 1 in such a way that both of them cannot actually concentrate and understand what their respective meeting is all about. So that's exactly what happens even on Wi-Fi. When you have people talking on channel 1 and channel 2, it leads to a lot of interference, and the experience or the Wi-Fi is not that great, because of which in wireless we actually use non-overlapping channels, so that whatever is happening on channel 1 is not heard by clients on another channel. And in common, 1, 6, and 11 is the most preferred channels that we use. So just one question. This is a question that I had when I joined wireless team, and I had asked my mentor. So can we actually use 2, 7, and 12? What do you guys think? It's okay, even if it's a wrong answer, it's fine. You can just probably try it out. Okay, no worries. So if you see channel 2, 7, and 12, it's very similar to 1, 6, and 11, right? They are also not overlapping. 2 is not overlapping with 7. 7 is not overlapping with 12. So theoretically, yes, we can use 2, 7, and 12 similar to how we use 1, 6, and 11. But why don't we not use it? Because specific countries like US, Canada, certain countries even in Europe, they do not allow communication on channels 12, 13, and 14 because of regulatory restrictions. So over there, if you go and design 2, 7, and 12, you cannot use 12. So you will only have 2 channels. So because of that, we always go and use 1, 6, and 11 so that we get 3 complete channels in the 2.4 gigahertz band. This is the channel overlap that I was actually talking about, wherein you can see how channels close to each other are basically getting overlapped, and then there's 1, 6, and 11 where there's absolutely no overlap happening. Yeah. So coming to 5 gigahertz band, the entire 5 gigahertz band is subdivided into Uni 1, Uni 2, Uni 2 extended, and then you have Uni 3. So Uni 1, Uni 2, and Uni 3, each of them have 4 non-overlapping channels which are 20 megahertz wide. It's very, very recently that in Uni 3 they basically added another channel called as 165, which is again 20 megahertz wide. Now in Uni 2, right now preferring 5 gigahertz because you can have multiple clients on different channels and no one is actually interfering with each other. Whereas in 2.4 gigahertz, you only get 3 channels to play with. Now again on 5 gigahertz, what channel your customer will use depends upon your country regulations. For example, in US, channels from 132 to 144 is not permitted because of regulatory restrictions. So yeah, that's one thing you'll always have to keep in mind. Before you deploy, you'll always have to see what that country regulation is with respect to different channels. Now, another thing that this slide also says is about 40 megahertz, 80, 160 megahertz. So what exactly is this? In 5 gigahertz, what happens is they give us an option of combining channels so that you have better channel width or better bandwidth. Like for example, you can combine two 20 megahertz channel to actually form a 40 megahertz channel. And then you can similarly combine two 40 megahertz channel to form 180 megahertz channel. And again, 280 to form 160. But what is the trade-off over here is when you're increasing bandwidth, yes, you're getting better data rates, but you have lesser channels to play with. Like for example, if I am going to deploy a 160 megahertz channel onto a customer deployment, I'll only have 2 channels to play with. So if the customer has, let's say, 1000 or 1500 clients, all it has is 2 channels. So it's very, very less, because of which there's a trade-off between the number of channels and the bandwidth that you want to use. So you will have to pick and choose wisely what fits well. So that completes our RF fundamentals. And what we'll now do is we'll start understanding what are the different components that you have in wireless, which will in fact help us understanding architecture as well. So when you come down to wireless, there are 2 important components. One is your wireless LAN controller, also called as WLC, and the other one is wireless access points, also called as wireless APs. So these are the 2 major components in any wireless deployment. So your WLC, in very simple terms, it's actually a network device that manages wireless APs. So let's say you walk into a Cisco office, and if you've seen Cisco office, each floor may be considered to. So it's not possible for me or any engineer to go and manually log into each of these access points and configure them manually, right? So that's where your WLC comes into picture. It's a centralized device from where we can actually push configs onto all the 50 at one go. And also WLC is like a single stop solution where you can log in and check what are the different clients connected to wireless at that particular instant, to which access point are the clients connected. If you want to make any configuration changes across all access points, you have WLC where it's just a single push and everything gets pushed over. So net, WLC is a centralized device which can actually be used both for monitoring as well as for management purposes. Now, very similar to a switch or a router, your WLC also has multiple ports. Console is something I think all of us over here are familiar with. We have a console port to which we can actually connect the console cable, gain access, and see what's happening in the device. Very similar operation also happens on the WLC. The next is your service port. Very similar to a switch or a router. It's used for out-of-band management, mainly for doing day zero or initial configs, like you want to assign IP addresses, define certain bootstrap configs. So that's where your service port comes into picture. Another usability is also when your management access goes down to your WLC, you cannot log in, you do not have anyone to give you console access. So you have your service port IP through which you can log into your WLC and see what went wrong. So your service port is typically connected to a switch port in access mode because it will only have a single VLAN to flow by. So it's always mostly put in an access mode. Coming to distribution ports that you actually see over here, they are actually used for control management traffic. And these are the ports that are connected to a switch port in trunk mode because over them, both control and management traffic flows by. So it has different VLANs that it needs to tackle, because of which we have it in the trunk mode. Now, like you can see in the figure, the distribution ports can be configured as a lag. I hope you guys are clear with the concept of lag, but for those who do not have it at the top of their mind, lag is wherein these individual links can be bundled to form a larger link. So the same applies true for WLC as well. So these are the important ports of a WLC. Now coming to wireless access points. So access points are basically devices that allow wireless clients to get connected to your network. So this is something that is sitting facing your client. And each of these access points broadcasts something called as an SSID. So if I have to make you understand, if you have come to Cisco office, you have a wireless network that gets broadcasted, which is called as Blizzard. So if you open your laptop or your mobile phone and you click your Wi-Fi on and then you go to your networks, you actually see a lot of networks getting broadcasted. So those networks in technical term is called as an SSID. And that SSID is actually broadcasted by these access points. And the process of broadcasting these SSIDs is one of the tasks, which is actually beacon generation. So there are a couple of other tasks also performed by the AP, like for example, probe responses. So what happens is there's also a provision wherein client can actually ask the access point if it broadcasts an XYZ SSID, wherein it sends a probe request to the AP saying, hey, do you broadcast this particular SSID? To which the AP responds by saying a yes or a no, and which is captured in a probe response. So these are some of the tasks that your access point takes into consideration. Now coming to CapWAP, we saw how APs and WLCs are two major components in your wireless architecture, and we also know that they have to talk to each other, right? Your WLC has to push configs to your access point, and for monitoring, your access point also has to push data to your controller. So how does this happen? So these two guys basically talk to each other via a protocol called as CapWAP, which is control and provisioning of wireless access points. It's a tunneling protocol very similar to other tunneling protocols like GRE and everything. And it carries both your control as well as your data traffic. So you have your control port as 5246 and your data port as 5247. So if someone asks you how your access point talks to your controller, it's always via the CapWAP protocol. Yeah. And when you deploy access points, there are different modes in which you can actually deploy these access points. And which mode to deploy depends upon your customer requirements. So Cisco has given you multiple flavors for multiple scenarios. You need to identify your scenario and then pick and choose the mode that you want to use. But from my experience, the most two commonly used modes are local mode and flex connect mode. So local mode is wherein both your control as well as your data traffic goes back to your WLC. So anything and everything that your access point gets, it simply forwards it to your WLC via your cap web, and from the WLC is where it goes out to your internet. Whereas what happens in Flex Connect is only your control traffic, that is your management traffic. For example, if you're logging in using your SSH or Telnet, all this goes to your WLC, but the client traffic or the data traffic is switched locally. So it does not go from AP to WLC via CapWeb. It simply goes out locally via the site. That's where Flex Connect comes into picture. You will understand more about Flex Connect when we discuss in the architecture as to why was a need to get this mode into picture. Bridge or mesh mode is when you want to cover a large area, basically an open area, and cabling every access point is not possible. For example, if you want to deploy wireless in a metro train, where cabling access points is not required, is not feasible. So what you do is you just have one cabled AP, which is like your root AP, and that root AP communicates to all the other access points wirelessly. So the all other access points which are connected via wireless is called as mesh APs. So mesh or bridge mode is coming into picture in those deployments where physical labeling or physical cabling of all these access points is not feasible. Monitor mode APs, they do not broadcast any SSID, they do not cater to any client traffic. It's only there for monitoring, as the name suggests. So it will observe your network and then give you details like, what are the rogue APs. So rogue APs are basically APs that are not part of your network. Like for example, in Cisco office, let's say there was another office like a Juniper or an Aruba that was running, and they have their own APs, then Cisco APs would actually call a Aruba or a Juniper AP as a rogue AP because those APs are not part of your network. So a monitor mode access point would detect such rogues and let us know about the position as well. And the last mode is sniffer mode. So we put an AP under sniffer mode only when we want to troubleshoot something. So for troubleshooting, we need packet captures. That is where you convert an AP mode into a sniffer mode, wherein it sniffs packets in that environment and then gives it to us. So we can then use analyzers like Wireshark to understand what is wrong with the environment, or reasons as to why interference is high. So it is during those scenarios that you convert an AP mode into a sniffer mode. Okay, now coming to the last section, which is very interesting one, which is the wireless architecture. So like I said, we have multiple flavors of architecture, and again, which architecture do you want to go by depends upon the requirements that you have in your hand. So when I'll actually walk you by the architecture, I will also try and make you guys understand what are some of the typical scenarios where each of these architectures will actually be used. So first is the autonomous AP architecture, wherein each AP is autonomous. So if you see in this diagram, you actually do not have a WLC. You only have your access points, and these are all your core distribution and access switches, which means that each and every AP is autonomous by itself. So there's no centralized WLC to manage or monitor these APs. The APs, a simple way of understanding this is the AP performs both tasks of a WLC as well as that of an AP. One typical example is, let's say you have a very, very small office of maybe 2 or 3 APs. Putting an WLC over there to just manage 2 or 3 APs would be an overkill. So rather than doing that, we can actually go in for an autonomous WLAN architecture where it's just 3 access points and they will manage themselves on their own. So that's a use case for the autonomous WLAN architecture. Now coming to cloud-based WLAN architecture, A very good example for this is Cisco Meraki. Not sure if you guys have heard about it, but it's a cloud-based platform for centralized management of network devices. So it does not just manage Wi-Fi, but it also manages switches, routers, etc. So NetNet is through a cloud platform. Your WLC will be on a cloud platform, which will actually manage your APs. It will also monitor your clients, and especially in Meraki, you can actually pull out reports as well about what has happened over a period of a week if you want to commit some analysis. So this is where it comes into picture. And I've seen this deployment going live, especially for customers where they do not want an appliance, like a controller appliance in their environment. They are okay to put it on cloud and just manage everything from there. So this architecture is basically for those customers. Then comes your centralized WLAN architecture, which is one of the most commonly and widely used one, where we have a WLC local to the site, which will perform both management as well as monitoring. So like I discussed earlier, we'll have access points scattered all over. Clients will be connected to these access points. The access points will communicate to your WLC via the CAPWAP protocol, and from the WLC your data traffic will actually go out. So in addition to your WLC, AP and your clients, we also have MSE CMX, which is actually location-based services, which provides location-based services. Like for example, if you have a use case wherein, you know, if you're entering a store or if you're entering a particular location, you want XYZ action to take place. So for that, you need to understand where that client actually resides in. So MSE CMX is basically a device that does that. But right now it's going LDOS. We have Cisco Spaces replacing MSE and CMX. And then you have network management. It's like a monitoring tool which would actually give us reports about what happens or what are the different scenarios that can happen in your environment. A good example is Prime, if you want to understand network management. And then you have distributed WLAN architecture. So if you remember when we spoke about Flex Connect mode, I told you I'll make you guys understand as to why this particular mode was required, right? So this architecture comes into picture for those customers who basically have small office like setup, maybe offices with 10-20 access points. So for 10-20 access points, autonomous architecture would not be a great fit. And then putting a WLC specific to 10-20 APs would also be an overkill. So that's wherein your Flex Connect solution comes into picture. So your WLC will not be sitting locally on that site. It will be in a data center, and the WLC in the data center will manage multiple site access points. So that is when you have Flex Connect mode coming into picture. And again, there are multiple flavors within Flex Connect itself. For example, in terms of switching traffic, you can have your traffic switched locally or centrally. What I mean to say is you can have your data sent all the way up to your WLC in the data center, and from the data center it will go out. So that's something called as central switching. Or if you do not want to use your WAN link so much, you can just have it switched locally out of your site and not go via the WAN to your WLC. Similarly, even I've seen customers who do not want authentication requests to go over your WAN. So we have two flavors again, central and local authentication. Central authentication is wherein all your auth requests will go to your WLC, and from the WLC you'll get your auth response. Whereas local is your AP will take care of your authentication. And in Flex Connect, you'll have two modes. So one major problem that you will always face in Flex Connect is because you have your WLC connected over your WAN link, what if something happens to your WAN? So your WLC loses connectivity to all the access points, and maybe that branch office can entirely go down. So what has been done in Flex Connect is, if in such a scenario WLC loses access to its APs, the APs will still function in a standalone mode, wherein it will still take care of its existing clients. It won't accept new clients, but whatever was running will actually run, because AP gets converted sort of into an autonomous mode. And that's where standalone comes into picture. Connected is the usual mode wherein you have your WLC in the DC talking to your APs over your WAN link, and you have your clients getting connected to the access points in the branch office. So this is something I had from a theory perspective. I think we have another 10 minutes, so I'll just give you a very quick demo of what the WLC looks like, what are the different tabs, what all you can see, because I think what you see will always stay in your mind rather than theory. So I'll quickly share my WLC browser as well. Can someone confirm if they're able to see the browser?
Yes, Anmol, it's visible.
Yeah, thanks, Rohit. Yeah, so I've opened the web UI for my WLC, and when I enter my credentials, this is what I get to see. This is it's basic. What can I say? A basic summary of what all is there in the network. So like I have two wireless network or two SSIDs that are active, 5, but I've turned it off. There are no access points right now. You also get to see what are your active clients on 2.45. What are the rogues, like I was saying, right? We can get to see what are the rogue APs, rogue clients. Then interferers also, like what are the devices that is interfering with your network on 2.4 as well as 5 gigahertz. So this is like a very, very brief holistic overview of what your network is all about. But if you want to go to deep, you just click on advanced and it will take you to the actual controller GUI. So under the first tab, monitor, here you will get a lot of information. So the first thing is it tells you how your WLC looks like. For example, the WLC that I am showcasing is a 5520. So you have a pictorial representation. You actually see your service port is here. Your redundancy port is over here. You have two uplinks, which is port 1 and port 2, and they are of 10 gig. So all these information you get to see. You also get to see how many APs the model actually supports. So over here with the license that it supports around 150 access points. You see what is your management IP, what is your service IP, what OS it is running on. So all these information you basically get to see on the monitor screen itself. If you want to go and see client information, you have clients over here. So right now, because there's no access point, you'll not see any client. But yeah, if you click on clients, if there are clients connected, you actually get to see a list of clients that are connected. You will also see client details, like what device is the client using, if it's using a Mac or if it's using a Windows or if it's a mobile device, to which AP it is connected to. So all of these also you will actually get to see under clients. Now, if you go, this is the section that I was talking about when I was covering SSIDs. So all of these are basically SSIDs that we have created. And you can actually create a new one by clicking over here, and it will actually tell you, like you can give your name, your SSID name, what needs to be broadcasted, and then you can define the policies associated if you want to have it as an open network or if you want to have it like a closed auth. So things like that, this is what it covers. Before controller, I'll go to wireless tab. So in wireless, here you will actually see all your APs that are connected to your WLC. So what all APs this WLC manages will actually be showcased over here. And then going to your controller, your inventory, you will get to see what is your WLC model, what's your burnt in MAC address, all those basic useful things that you need. You will also see how different ports are, what is turned on, what is turned off, and things like that. So basic controller related information is something that this tab actually captures. So security is wherein you go and define your auth servers. Like when I was covering Flex Connect, I spoke about central auth and local auth, right? So for authentication, if you're using ICE or any other servers, you can define all the servers over here under the security section. And management is wherein you define your telnet SSH related configs, or if you want to define your SNMP traps, or if you want to see local management users. Like for example, I logged into the WLC using local users, which is admin. So all this is basically defined in this section. And then under commands, this is wherein you want to when you want to upgrade your WLC, this is where you come to. So you actually upload a code and then you can get your controller upgraded. But in addition to that, it also gives you multiple. You can also download configurations, upload a WebAuth bundle. So there are multiple functions that happens under cloud. Yeah, so this was a quick walkthrough of your WLC. I do not have APs currently on this WLC, because of which I cannot show you access points. But yeah, I hope I've given a touch and feel of how the WLC looks like.